Welcome to these notes in which we will talk about basic alcohol nomenclature. For straight chain alkanes, alkenes, and alkynes, we will continue to find the longest carbon chain. This time, though, they will contain hydroxy groups. We are going to put the OH on the lowest number for the chain. That means it takes priority over multiple bonds, halogens, and alkane branches, meaning now OH groups will get the smallest number. We will name any other branches as we always have, but the ending will change. Now we will remove the final E from the parent chain and add the ending OL. If there are more than one OHs present, we will get a diol or triol. Okay? So let's start by doing two examples, and you should probably catch on pretty quickly because if you know how to name alkanes and alkenes, again, the rules are mostly the same. At this point, we're going to take a look at the one on the left. There's nothing here, there are no branches, there's no double or triple bonds, so I'm going to number starting on the right-hand side because that is closest to where the OH is. Now, if this were a normal problem and there were no OHs here, this would be hexane. That is the name of our parent chain. But because this is an alcohol, we are going to number the location and change the ending from an E to an OL. So this will turn it into 2-hexanol. Again, all with a 2 at carbon 2. So 2-hexanol. On the next one, we do have a methyl branch, so we need to be careful still to give the OH the lowest number. 1, 2, 3, or from the right, 1, 2, 3. Now, because the OH is in the middle, it really doesn't matter, quote unquote, which way we number it. But I'm going to number it from the right to give the methyl group the smaller number overall as well. So in this case, we still have 2-methyl. And then we have 3, 4, 5-pentanol. I can count. So again, we have a methyl on 2, that's what that tells us. And we have an all on the pentane chain at carbon number 3. So 1, 2, 3, 4, 5 is pentane, so it changes to 3-pentanol with a methyl on 2. So again, all of our names are really all of our rules are staying the same. We're just going to give priority to the OH groups, and we're going to make sure we number them out in front, just like any other group. For cyclocompounds, we do not need to number the OH group if there's only one of them. It's implied that it exists at carbon number 1. Just like before when we had methyl cyclohexane and we did not number it if there was only one group. The same with these alcohols. Now the ending will still remain the same. So this would normally be cyclohexane. Okay, cyclohexane. However, because again this is an alcohol, we chop off the E and add an all, turning this into cyclohexanol. Alright, and again, you could put a 1 out here, but if there's only one OH or one thing around this ring, it's implied that it happens at carbon 1. If another branch exists, the branches go so that they will get the lowest total set of numbers, and the OH will come first in priority. So for something like this one on the left, 1, 2 will be the way I number this. So this would be 2-methyl, 1-cyclopentanol. Pentanol. So we have a methyl on 2. We have a all on 1, and it is a cyclopentanol. So again, that got the lowest set of numbers. The one on the right here, which is a little bit more complicated and going to probably run off the end of the page, 1 would be over here, and it doesn't matter which way we go because they're going to be on 4 no matter which way we go around. So this would be 1, 4 dimethyl because there's 2 methyl groups, 1, 4 dimethyl, 1 cyclohexanol. So again, we have a dimethyl, 1 on 4, 1 on 1 and 1 on 4. And we have a cyclohexanol on number 1. So very simple to do these cyclic compounds. The only time where naming alcohols gets a little funky is with double and triple bonds. And the reason for that is because the ending is already not A-N-E, it's E-N-E or Y-N-E. And because in the past, we've numbered the double bond out in front. So what we end up with is two different naming conventions that are pretty similar. Let me show you what I mean. If this did not have the OH on it, it would look like this, okay? And I would number it like we normally would. 1, 2, 3, 4, 5, 6. So under normal circumstances, if that OH was not there, it would be trans 3 hexene, where again the 3 refers to this ene. Now, because the alcohol also has a number out in front that refers to an ending, we can't really name it the same way, because then we would have two sets of numbers here and two endings here, and we wouldn't know which one belongs to which, right? So with alcohols, what we're going to do is we're going to put the number for the alcohol not at the start, but between the ending of the parent chain's name and the OL. What I mean by that is, here the alcohol happens at 1. So instead of this being called trans 3 hexene, it's going to be trans 3 hexene. But in between the all, which needs to happen, and the ene, we're going to number it. Trans 3 hexene 1 all. That way, this 3 is very clearly for the ene, and this 1 is very clearly for the all, and they're not both in the same place. Otherwise, we would end up with like 3, 1, hexene, all, and is the 3 for the ene and the 1 for the all, or is it the other way around? We don't know. So that's why we always take this ending and we break it up the way we have it here, with the number in between the ene and the all. In the second example, we can do the exact same thing. We have 1, 2, 3, 4, 5 carbons, again starting closest to the OH. We have a cis double bond at 2 and 3 to think about, and the OH itself. So again, cis and trans always will go out in front. So this is cis 2 pentene. But before we add the all, we number it 1 all. So cis 2, 2 to the ene, 1 all, 1 referring to the alcohol. So that's it in a nutshell. The biggest things are to consistently remember that you have to number starting at the OH and nowhere else, which is a little bit of a change up. And again, I think the biggest thing is remembering that on enes and ines, which we haven't really done any examples for, that you're going to need to add that number in between the ene or ine and the all, so that way they can be numbered properly. Other than that, everything we've done so far continues to hold true. Please try the last 2 pages here of examples, and we will go over them in class on the next time I see you. All right, have a good one. Thanks for watching.